Okay, we are looking at the topic 11 and 12 review. This is also the review for DCA number 5, everything that you would ever need to know about circles. So, as we look at question number 1 right here, it is asking about angle FDH. Angle FDH is this one that I'm outlining right now, and that's the angle that's asking about. And we can tell looking at this diagram that angle FDH is going to be the same as if you added together this 40-degree angle right here plus this missing part right here. Okay, that missing part is what we're going to be looking for. So something else that I notice in this diagram is that as you look across right here, going from I to F, I see a diameter of the circle. Now, something we know that when we think about circles and we think about degree measurements, something we know is that a full circle should add up to 360 degrees. So if we're cutting it in half, like we have here with this diameter that's highlighted in yellow, if we're cutting it in half, all of the pieces on one side of that diameter should add up to 180. So what I see is we've got 76 down here, we've got 40, both of those already labeled. It's going to be a quick and easy fix to find this missing piece because all we got to do is subtract that from 180. Okay, we know that all three of those pieces should have to add up to 180, and so that makes it pretty easy to find our missing part, 64 degrees right there. Now, when we talk about angle FDH, that part that I outlined right there at the beginning, I'll do it again right here. That part that I outlined right there, we said that it was going to be the sum of those two pieces. So if we're looking for that answer, it's pretty quick and easy again. We just add them together, and that's our answer. 104 degrees is our angle FDH. Going on now to question number 2. Question number 2, I've already got a few things highlighted on that diagram. As we look at the question is asking about HGJ. Now, when we ask about the measure of an arc like this, when we ask about the measure of an arc, we know that that's related to the angles that the arc makes. So what we're going to do first is we're going to find the measure of arc GH. And when I look at that line that I've highlighted in blue, that's another diameter. So we know, just like in the previous problem, that if we take these three pieces on the right side of the diameter, they will add up to 180. So if we're looking for this missing one here in the middle, we're looking for arc GH, you can just subtract 180 minus those other two pieces. 180 minus 137, that gives us GH must be equal to 43 degrees. Now, I'm going to erase some stuff on here, and I want to draw your attention now to actually, we'll keep that one. We'll say that that's 43. Okay, now I want to draw your attention to this line. Okay, this line now going from J to G, that is another diameter. Okay, and we know that everything on the left side of the diameter and everything on the right side of the diameter, all of those pieces add up to 180 degrees. That diameter cuts the circle in half. Okay, so that means everything on the left, okay, all of this part of the circle over here, all of that is 180 degrees. Okay, so really, when we look at our yellow arc, the answer that we're trying to get, the measure of arc HGJ, when we look at trying to find the yellow arc, all we're really doing is adding 180 plus this missing piece that we found. 180 plus 43 gives us our answer, 223 degrees. Moving on now to question number 3. Question number 3 is asking us to find the length of the arc, and it is talking about, just in case you can't really tell on your screen, it is talking about this arc right here, the bolded part. Okay, so the formula for finding the length of an arc is a pretty simple one. You take your circumference, which is 2 times pi times r, and you multiply that circumference times the angle fraction, theta over 360. So in this case, 240 is going to be our theta, and 11 is going to be our radius. And it turns out to be super simple after you just plug those things in. 2 pi r is 2 times pi times 11, which is 22 pi. So that's the first part of it. Okay, that's the first part of our formula. It goes right in there. and we're going to multiply it times 240 over 360. All of that can simplify down, or you could type it into your calculator. As just 240 over 360. Whatever, either way that you want to do it, you end up with an answer of 44 pi. Should be 44 pi over 3. 44 pi over 3. Okay? If you're talking about, if you are trying to figure out your answer in terms of pi, make sure that what you type into the calculator, the thing you type into the calculator is 22 times the fraction. Okay? Make sure that if you're trying to find your answer using a calculator, trying to find your answer in terms of pi, you are not typing in pi into the calculator itself. All right? So that's how we get this answer of 44 pi over 3. Moving on now, this one is asking about the area of a sector, which actually ends up being a really similar formula. Okay, we're still going to have our old theta over 360, except this time instead of multiplying times circumference, we're going to be multiplying times area. Area is pi times the radius squared. Okay, so that's the first part of it. As we look at our diagram, our theta is 135, our radius is 15. So if we're looking for the area, it's pi times r squared. It's pi times 15 squared. So our area is 225 pi. Okay, this is the thing that goes right there. Now, if we're trying to find the area of just that sector, we multiply that 225 pi times the fraction, 135, our theta, over 360. Okay, this is something that you can type into the calculator. If you did it like that and you typed in everything except pi, it would give you an answer if you use your old friend MathFrac. Okay, don't forget about that. MathFrac. A really helpful tool in the calculator, okay? That'll give you your simplified version of all of those fractions. We end up with 675 pi over 8. All right. This next one, write the equation of a circle, and it gives us the center, and it gives us the radius. So first thing we need to know about the equation of a circle is that it always looks pretty much the same. Okay, it always looks about something about like this: x minus a squared, and then we've got y minus b squared, and then we've got r squared. Okay, when you look at this equation, a and b both come from the center point. Okay, so on the left side of your equation, you're going to have x, and y, and you're going to have that. Okay, on the left side of the equation, you're going to have 8, and you're going to have 4. Okay, but let's talk about this. Something you need to pay attention to is that in our point, our coordinates up here, we had positive 8 and negative 4. Well, when we put that into our equation, that becomes negative 8 and plus 4 when you put it into the equation. Okay? So don't get that mixed up. It's a really easy thing to mix up, especially on a multiple choice test. They will give you everything in this problem right, except it would say plus 8 and minus 4. And that would be a wrong answer on a multiple choice test. That's something you got to be really careful with. Okay? This last part of it, r squared over here, is talking about the radius. Okay? So it tells us that the radius is 3. R squared, our other side of the equation, is going to be 9. So that's our answer, x minus 8, y plus 4, and then we take that radius and square it for the other side of the equation. Going on now to almost the same question, write the equation of the circle. Okay? This time, instead of giving us that information, we have to find it for ourselves. So as we look at this diagram, the center of our circle is going to be right here. The center of our circle, that point is at 0, -3. And as we look at our radius, what we're going to do is we're just going to count how far it is over. 1, 2, 3, 4 points to the edge of that circle. So our radius equals 4. if we are plugging this information into that equation, it's going to be x minus 0, so it's just x squared. Okay, you don't have to write x minus 0. Don't forget that that is the exact same thing. X minus 0 doesn't actually change anything. And then we're going to have y. We're going to have the y, and we're going to have the r squared, okay? In this second set of parentheses, we've got minus 3 for the coordinate, so that means we've got to have plus 3 in the equation. Our last part is the radius squared. If our radius, as we counted over here, is 4, then that means the other side of the equation has to be 16. Okay, it's got to be 4 squared. All right, this next problem uses one of our theorems from topic 12. That theorem said that if this line segment right here is tangent to the circle, then that means, and it runs in and it intersects a radius, that means this must be a right angle. Okay, so if that's a right angle, first it tells us that LM, it tells us the radius is 5, and tells us that LM equals 8. Okay, let me give you a secret. The secret to this whole problem right here is that JM is also a radius, so it is also 5. Okay, you also notice that this picture is not drawn to a very good scale. That's kind of how it goes on most of these problems, especially on the DCA. They'll give you like whatever picture they really feel like doing, and it doesn't really matter if it looks if the numbers like look accurate or not. You just have to go by the math instead of what the picture gives you. Okay, so if we're talking about this triangle, okay, what I'm going to do is I'm going to draw the triangle just by itself. Okay, just the triangle without any of that other stuff. With the circle, we've got 5, we've got 13, and it's asking what is KL. So it's asking for this thing right here. Whenever you're dealing with the side lengths of a triangle, it's just Pythagorean theorem. Okay, a squared plus b squared equals c squared. In this example, a and b are going to be your two legs, 5 squared and x squared. C squared is your 13 squared. Okay, and after this point, it's just solving for x. Okay, you subtract the 25 from both sides. You know, with x squared equals 144. And how convenient is that? That it gives you a whole number answer. This right here turns out to be the square root of 144, which is 12. This next problem is tricky, and that's how they get you. Is something like this where it really you don't even think about it until it calls back to something from I believe in the 4th 6 weeks when we talked about this. Okay, this one tells you that KL equals JK. So go ahead and put some markers on there. KL and JK are the same length. Okay, so we need to think about that just as a triangle by itself, separate from this diagram. We've got a right angle here. Okay, we know that from that theorem. We've got a right angle, and we've got one leg and one leg that are the same length. Okay, this is one of our special right triangles, and when both of those legs are the same length, that also means that both of these angles are exactly the same. We also know from way back at the beginning of the year that every triangle always adds up to 180 degrees. So if this one is 90 and both of these are the same, then that means they both have to be 45 degrees. 45 degrees. Going on to this next one, we're getting close to the end. Tells us that JK, KL, and LJ are all tangent to the circle. Okay, it tells us that all of the sides, we've got what is called a circle circumscribed inside of that triangle. It tells us that JA equals 9. It tells us that AL equals 10 and CK equals 14. Okay, so all of those were labeled. These things that I'm highlighting right now, these are the things that were given. It gave us JA, it gave us AL, and it gave us CK. What we have to remember is the tangent to a circle theorem that tells us if you've got two segments that start at the same place, that are tangent to a circle, they're both tangent to the same circle, then those segments are the same length. That is how we figured out that these two are equal. And that's how we figured out those two pieces are equal. And that's how we figured out that those two pieces are equal. When it asks about the perimeter, we know how to find the perimeter of a shape. Okay, perimeter of a shape is just adding up all of the side lengths. So we add up all those pieces, 9 plus 9, all the way around. Okay, and that's just simplifying it down. Your perimeter turns out to be super simple to find. Turns out to be 66. Going on to, I believe this is our last question. Okay, this last question is a tricky one too. Okay, it tells you that we have a given radius and a given arc length. It's asking for the measure of theta, the central angle. So here's what we have to think about. Okay, we have to think about our formula for the arc length. Okay, the way we found arc length was that we said S, the length of the arc, equals the circumference, 2 pi r, times that fraction, theta over 360. Okay, here's the thing. This time, we're not only plugging in stuff on the right side of the equation to find S. We already have S. Okay, this is S. So we're going to have to manipulate this equation and end up somehow with theta by itself. Okay, so let's first talk about the circumference part of it. That's pretty easy to find. It's just 2 pi r. So 2 times pi times 2 again ends up being 4 pi. Okay, that's the part of the formula that goes right in here. Okay, we already knew that. But when we're dealing with this equation, it ends up being different because we already have the arc length. That's where this came from. Okay, 10 pi over 3 is the arc length. It wants us to find what angle goes with that. Okay, so what happens here is we've got 4 pi times theta over 360. Okay, if you're multiplying 4 pi times theta, you can just make that 4 pi times theta over 360. That's a perfectly fine thing to do. We want to ultimately end up with theta by itself. This is the thing that we want to try and get by itself. So what is happening to theta? What's happening is that it's getting multiplied times 4 pi and divided by 360. We can undo both of those things at exactly the same time by dividing by 4 pi and multiplying times 360, all at the same time. Okay, that's why we have this whole mess of stuff going on right here. It's so that we can divide and multiply, and what it does is we end up with 4 pi and 4 pi canceling, and 360 and 360 canceling, so that all we have left is just theta, like we were trying to get. Okay, and when we do that on this side, it ends up being a whole mess of stuff, okay? Because on this side, you end up with pi's on top and bottom. You end up with 3,600 over 4. Or no, 3,600 over 12, excuse me, which is 300. That's where this whole answer came from, okay? That's a mess of a problem, but it ends up being a really good one, and it ends up showing you some interesting stuff about algebra and how multiplying and dividing, you can work all of that at the same time in one big step. So that's all we're going to have for part 1 of the review. Our next video will be part 2. That's all we got. Thanks.